All right. Hi, I'm Heather Arcos, and this is my Module 3 Excel report. Okay. First one is on theoretical probability and empirical probability. Okay. Theoretical probability is probability based on reasoning, written as a ratio of the number of favorable outcomes to the number of possible outcomes. So, like on here, we did our little charts. An empirical probability is a ratio of the number of outcomes in which a specified event occurs through the total number of trials, not a theoretical sample. So these right here are the theoretical, I guess. So what is that? The sum of two, or the, yeah, that's the product. The difference between theoretical and empirical probability is that empirical probability is of an event is an estimate that said event will occur based on how often the event occurred after collecting data from an experiment. In a large number of trials and theoretical probability, you don't actually conduct the experiment. As the sample size increases, the distribution of empirical data decreases. Let's look at our charts. So these are our sum of 2 with the 6 rows on this chart right here. On that, push enter, you see it changes. Then on 60, 600, find my chart. See, it'll change. We did the random. So every time we click and change it, our information changes. The same with the product. This one is 60 rows. Show our 600 as it changes, and 6,000. See, even though there's more numbers, it kind of seems to stay similar. All right, on the scenario 2, our binomial. Okay, normal distribution is a continuous distribution that arises in many natural processes. Continuous means, that between any two data values, we could find another data value. Binomial distribution is very different from normal distribution. But if the sample size is large enough, their shapes are going to be quite similar. Where do I have? The key difference is that binomial distribution is discrete, not continuous, meaning it is not possible to find data between any two data values. And then we have our lottery charts. So I did a Texas lottery showing what percentages go to what. On their prizes paid, the largest amount, 65.1%. They do put some 0.03% towards veterans assistance and other state programs. It's not very much. And the education is 25.5%, so they do spend quite a bit on their education in Texas. For Colorado, Most of theirs seems to be towards outdoors, wildlife type stuff. They have the Conservation Trust Fund at 40%. Their education is only 3.75%. That's all they spend on their education in Colorado. And this is the proceeds from the state lotteries, where their money goes. They do spend a lot on the Great Outdoors Colorado Fund at 45.65%. And Arkansas, most of our state lottery proceeds go to prizes. So most of the money that gets spent or people buying it, it goes back to those prizes, 69%. Scholarships, they use 22%, so it's not a whole lot, but it's pretty good. And then for their administration costs is 9%. Okay, let's move on to BMI. All right. BMI is someone's weight in kilos divided by the square height in meters. High BMI can indicate body fatness. It can be used to screen for weight categories that may lead to health problems. That being said, it's not a diagnosis of obesity or the health of an individual. Some might have a high BMI, and also still be healthy. It calculates the weight of a person, assuming that it's only fat, but it could be because they have a higher muscle. They have higher muscle density in their body. The confidence interval for each set of data means that the range of values is defined, that there's a specified probability that the value of a parameter lies within it. Our z-score is the number of standard deviations from the mean of a data point. It's a measure of how many standard deviations below or above the population mean a raw score is, also known as a standard score, and it can be placed on a normal distribution curve. So on those, I did mine, my daughter's, and my husband's. Where are the charts? Okay, so I used the BMI calculator that we had on that link. Mine is 29 months, pretty high. My husband's is 28, and my daughter her BMI is 20. She is very skinny. So yeah, I'm kind of in it says moderate, but I need to work on that. This is my daughter. She's in the green, so she's got a low BMI. And then my husband's is in the moderate category as well. So maybe we need to work on that a little bit. And depending on where you live in the US, you can determine if you have a lower or higher probability. Did not. Okay. If you live in Colorado, and I got this information from the website, you have a higher probability of having a healthy BMI because Colorado has a lower percentage rate of obesity at 20 to 24%. Arkansas has one of the highest percentage rates of obesity at 35% or more. This means you have a lower probability of having a healthy BMI. The average tells the sum of the values of all data points divided the amount of numbers collected. Standard deviation tells us how tight or how spread out the data is from the mean. This calculates how the data points are reproduced. It is also the positive square root of the mean of the square deviations from the mean. The z-score is a numerical measurement used in statistics of a values relationship to the mean of a group of values, measured in terms of standard deviations from the mean. Confidence interval is a statistical range with a specified probability that a given parameter lies within the range. It just tells you how confident one is that the analysis is correct. So let's just look at But yeah, my daughter's is on the low side. I'm kind of over the mean. I'm over the mean for the average. And my husband's is also over the average. All right, let's move on to simple and compound interest. All right. Interest is the money paid regularly at a particular rate for the use of the money lent or for delaying the repayment of debt. It exists for borrowing because nothing is done for free. If you want or need to borrow money, a bank or financial institution is going to get something out of it. No one does anything for free. That means they get to make a certain percentage of the amount you borrow, and the same goes for investing. If you invest your money, you want to get more back than what you invest. The difference between simple and compound interest is that simple interest is there's usually one interest rate that you will pay back along with the principal amount that was borrowed. Meaning you only pay back that percentage every time you make a payment. And with compound interest, you're paying back more interest. You're paying interest on not only the principal, but on the interest as well. So you're paying interest on interest. The benefit of using, let's look at this. Okay, so on this one, we had a principal amount that is how much we borrowed. Yeah, that's how much we borrowed. And with the simple, you can see, the years, it just adds up on the interest. The interest rate that we used was 6%. The time, and it goes all the way from 0 to 10 years. And then we did the number of times compounded. That was 4. So on here, on our simple interest, we did our principal interest, and then we multiplied that by our interest rate, and then times the amount, the year. So that gives us that. So if you pay it back right away, you don't have to pay any interest. If you wait a year, you're gonna add more interest on there. It goes up a little over $200, and then so on. Okay. Our houses. Okay, and the benefit of using money that you have set aside for eating out on making extra mortgage payments, it goes to this right here. If you pay, your mortgage would just be paid off faster, and you would be paying less interest. If it gets paid off faster, your interest just doesn't accumulate as much as you were if you were only making the minimum. So that's it's not easy to do, but if you can, it's definitely worth it in the long run. Because right here it shows us if you, on this example, the cost of the house, $120,000. You want to pay 8% down, so you're going to have $9,600 down. So the principal that's still left over is $110,400 at 5% interest rate. So your monthly payment if you paid it off in 5 years, your monthly payment is a little over $2,000. And that you only pay $14,000 in interest. And if you do the 35-year loan, you're paying less every month, not even half. But look how much interest you have to pay. That's, double the cost of your house. That just doesn't seem worth it. So down here it shows us, I think I chose the 30-year. Yes, I chose the 30-year plan for this one. So the 30-year one, you're going to making a smaller monthly payment if you don't add any extra to it. It's $593 rounded up. So to pay that off, it's 359 months. So you're going to be paying $212,000, and your interest is over $100,000. If you can, I would definitely choose to do this. You pay the extra $100 a month on your payment, cuts down the months that you have to pay quite a bit. Your total paid is less and your interest is less. So that is definitely worth it if you can afford to do that. And these are just our charts explaining all of that. Okay. All right, subsidized loans and unsubsidized loans. They're very different. Subsidized loans do not, do I have any charts on this one? I don't. Oh, yes, I do. Okay. So our subsidized loans means, sorry, they do not accumulate interest until the student graduates or leaves school, and they usually have about 6 months after graduation before any interest starts accumulating. Unsubsidized loans, they begin to accumulate interest as soon as you take out the loan. Paying interest is just always going to happen. If you have any type of loan or credit card, there's just no way around it unless you just pay everything in cash. Let me see. There are ways to minimize those interest payments, though. One way, you can look for lower interest rates on loans or credit cards, and always pay on time. Don't have late payments. Otherwise, your interest goes up and you have late fees. And if you always pay on time, maybe they'll lower your interest rate for you or on the next loan. Another way is to pay more than the minimum, just like with our house payment. If you pay more than the minimum, the debt gets paid off faster, and that just means you have less interest accumulated. So this is our chart on the subsidized and unsubsidized student loans. So the subsidized, you can see you have your principal interest, or your principal loan that you took out, $12,000, 3.5% interest rate. And that one does not accumulate the interest until you graduate. So that one, with you're paying back a little over $2,000 more than what you took out. That's not too bad. If you do the unsubsidized, like I said, the interest automatically starts accumulating. So that way you're paying back, and that one is $3,000. Yeah, that one you're paying back quite a bit more. Okay. Okay. Let's move on to the sampling and the population. Okay, random sampling is the basic technique where we select a group of subjects for a study or survey from a larger group from the population. Each individual is chosen entirely by chance, and each member of the population has an equal chance of being included in the sample. With stratified sampling, the researcher divides the population into two separate groups called strata. Then a probability sample, often a random sample, is drawn from each group. Volunteer sampling is a sampling technique where participants, they self-select to become part of a study or survey. They volunteer for it. Convenient sampling, also known as grab sampling, is a type of non-probability sampling that involves the sample being drawn from that part of the population that's close to them. A good survey topic that would be appropriate to use volunteers, or a convenient sample to collect data, that would probably be like a satisfaction survey. Those are the ones like, okay, you always get the emails, hey, do you want to do this? If you volunteer for it, you usually are going to have, I guess, something probably good to say. So I guess that would be just convenient for them. Population and sample are important when using data to project probability onto a larger population, because if the sample's too small compared to the actual population, then the data that comes from that survey or study will be off. It's not going to be right. It's going to be off, and you're not going to get an accurate result. If the sample is too large, the same thing happens. The data you're going to have skewed data. Using data from one population to project outcomes on another population can create confusing and misleading data because the results will be based on one place or people, and that data may not be true for another group of people. Let's just say, like in this one, we looked at this information from like the Republican ratings of President Trump. Of course, he's a Republican president, so let's say 87% of Republicans approve of him. 12% of them disapprove, and then we have no data for one. But then we can go down here and look like at the independent. If we tried to use the information from the Republicans and then based it on like independent approval ratings, we can't do that because their numbers are completely different. They have 34% approval rating for President Trump, the independents do, 63% disapprove. And then we can go down to the Democrats and look at them. They only have 8% approval rating for President Trump. And then they have 90%. So if we try to use, say, this information, if we chose them and said, oh, well, that's going to be the same for another group of people. Well, it's clearly not. It's basically completely opposite. So that you just can't use that. And that just shows the percentages of Republicans, and I got the population the day that I did it, which I know it changes every second. We have 328, what is that, 1,767,539. And out of those, 27% of this right here are Republicans. 44% of them are independent, and then 26% are Democrat, and then only 3% unknown. Let's see what else I have over here. Those are just my charts for that. Oh, and this is the military one. Okay. All right, now let's look at our 3D graphs. This one I thought was pretty cool. It's a little tricky to try to get it to just kind of fill in some numbers. So this one just filled in numbers right here, kind of color coded a little bit. Move this up, make it bigger so y'all can see what this does. So you select it and you put a surface graph, and then let's rotate it. Maybe not. Oh, no, I know what to do. Okay. Do our 3D rotation. Just see how it changes when we perspective with it. We can kind of look at it this way. And underneath, I thought this one was really cool. Okay, and I have other charts. This one, I just kind of randomly put numbers in there to see what I can make. I kind of like how this one came out. It has all these little ridges. Kind of looks like mountains a little bit. And watch as we, oh, wrong way. Oh, that was the bottom part. Looks like stairs. And then this one. This out of the way. And this one too, I just randomly put numbers in just to kind of see what I can make. Just like a little box. Yeah. I think I have one more. Oh, it did. Okay. Okay, this one, let me find the numbers I did. Oh, I kind of tried to make this one look like a fish. That is not how the graph came out. This one came out a little weird. I still like it though. Yeah. I guess you can kind of see the shape that I was going for. It just doesn't have the like the face of a fish. There you go. You can kind of see it. Like that would be the tail and all that. I tried. So I believe that is it for Module 3. Double check. Yes, I did all of these. Okay, that is it. Thank you.